Okay, so here's a quick review of some of the things we did last time. So we were talking about expectations of pairs of random variables involving pairs of random variables. So in particular, we said the expected value of g of xy is defined as the double integral of the function g of xy times the joint PDF, right? And if this was discrete random variables, I would have had the summation, right? And the PMF. We also defined something called the correlation. So correlation क्या होती है? Correlation we defined as Rxy between two random variables x and y was defined as nothing but the expected value of xy, right? What was the covariance? Right, so covariance was cxy was equal to x minus mu x, expected value of x minus mu x times y minus mu y. Right, so it's covariance between two random variables is actually the correlation after the means have been subtracted or after the biases have been removed. And what was the relationship between the two? So we said the cxy equals Rxy minus the product of the means. Okay, or yeah, and we also said if Rxy equals 0, what are the random variables called? We say the random variables are Ghazi? Random variables are said to be what? G Mohsen?
So uncorrelated.
No. They're said to be orthogonal. Okay, so they're said to be orthogonal. Or I mean, this is often a sign that we use, right? So, and if the covariance is 0, then the random variables are said to be Mohsen uncorrelated, right? So there's a difference. That's the definition that we said. This is the standard definitions. Okay, and then finally we define something called the correlation coefficient. Correlation coefficient. And what was that defined as? Rho xy was defined as covariance between x and y divided by the product of their standard deviations. And we also said without a proof, and the proof is there in the textbook, by the way, that the correlation coefficient, the magnitude for that is always going to be less than or equal to 1, right? And is 0 only if the random variables are uncorrelated, and rho xy equals, the equality only holds if and only if y equals cx plus b, right? So one is an affine function of the other, right? That is when the correlation coefficient turns out to be equal to 1, right? So this is just a quick review of what we did in the last class, in particular in reference to expectations of pairs of random variables. Now we're going to continue the discussion. Okay. So we're going to continue that discussion here and start talking about conditional expectations. Okay. So we want to talk about conditional expectations. Right. So I may be interested, for example, in finding out what expected value of x given y is. Right. And the kind of applications that you would be interested in finding this conditional expectation, for example, could be, let's say x is the age of a child, or the weight of a child, or the right. So the weight of a child, and y is the height of a child, right? And you say, given that the age of a child is 5 years, what is the average weight of children who are 5 years old, right? So this is the kind of things that you may ask, right? So what is the average, or in other words, what is the average lifetime of a person given that he smokes this many number of cigarettes per day, right? Average lifetime, right? So this is another could be let's say you have a sensor which is making some measurements, and you say, okay, given that the original value that you know is whatever 25 degrees centigrade, what is the expected value of the measurement that you could expect? And that's random, of course, because of noise. Okay? So these are the kind of questions that you may ask with two random variables, right? और इसकी definition क्या होगी? Can anybody take a guess? Just what do you think? I mean, how should this be defined? The expectation of a random variable x, given that the random variable y has been observed to be equal to some value. So let's do this here. Like, given that the random variable has been observed to be some value, given that the age is equal to 5 years, right? So what is that expectation on x? What should that definition be? Ji Shoaib, please go ahead.
I will try. So हमने पहले ये किया हुआ है, लेकिन y is capital Y equals to y की जगह capital A होता था. So integral from positive infinity to minus infinity x into f of x given by
Good.
dx.
Right. So this would be x and f x given y. So the conditional PDF that we've defined before, right? And integral is over, of course, over dx, right? And at the end of the day, when you are done with making this evaluation, right? Remember, this will be a function of y. Everybody sees that, right? I mean, this is going to be a function of y. Why? Because, I mean, y just stays there. That's given. That's an observation that you've made. For different observations, this expectation is going to be different, or this expectation may be different, right? For any given observation. As the observations change, this conditional expectation may be different. And that's very, very intuitive. So the average weight of 5-year-olds is not going to be the same as average weight of 10-year-olds. Okay? So it turns out this conditional expectation is a function of the conditioning, right? It's the function of what value the conditional random variable takes. Okay? Now this can be generalized, and I can say, okay, what is the expectation of g of x? I can generalize this given y. What do you think this should be, Salar? So the kind of question I may trying to answer here is, what is the say, for example, the average weight squared of 5-year-olds, given that they are 5-year-olds? Salar, can you hear me?
Yes, sir, I'm here. Yeah, I can hear you.
Can you try to answer? I mean, what should this be equal to?
It should follow the same convention that we just did.
Yeah. So I mean, if you could just write it out for me, or say it out loud. Okay, what should I write?
G of x obviously in the integral,
Yeah,
g of x, whatever that function on x is,
yeah.
and then the conditional uh, f of g of x given y.
F of x given y, not g of x given y, right? So this is x given y because the integral
But
is
we
going
don't know
to
what
dx.
that function is yet.
You don't know that function is, and that function is here. That function is here. G of x is here. It's just like expected value of g of x. I mean, without, even if you did not have that conditioning, what is the expected value of g of x? You integrate or find the average value of g of x and multiply that with the PDF of x, not with the PDF of g of x.
Right, sir.
And you would get the same results, by the way. अगर आप जो g of x की PDF से multiply करें, तो फिर then you would have to integrate over g of x as well. And that's just, so this is a side note here, by the way. Okay, maybe something for you to try to prove for all of you, right? If I say y equals g of x, right? And I say I apply the transformations and find fy of y, right? And I compute expected value of y through two ways. This is integral y fy of y dy, or expected value of y is equal to expected value of g of x because y is a function of x, right? And this would mean that this definition should be g of x fx of x d of x dx, right? And you try to prove कि यार ये जो this equation and this equation prove that they're the same. They would yield exactly the same result. So there are multiple ways of finding that expectation. Okay, so this is on as a side note, if you will. Okay. Achha, so this is coming back. This is the conditional expectation. This is the conditional expectation. Okay. Let's do an example here. Yeah. Or example one, if you will. And that is that if you're given f of x given y, x given y equals root 2 upon 3 pi expected value of minus 2 by 3 x minus y by 2 whole square. Okay. And I ask you to find expected value of x given y. What is this going to be equal to? जी ईशा, what is this going to be equal to? चलिए आपने खुद याद कर दिया.
This f of x given y.
Yeah.
So उसका इंटेग्रल लेंगे, इंटेग्रल फ्रॉम माइनस इन्फिनिटी टू इन्फिनिटी टाइम्स ऑफ x टाइम्स ये जो ऊपर पूरा एक्सप्रेशन लिखा हुआ है.
Yeah. Actually, that was not. Okay, ठीक है. What I'm more interested in is इसका आंसर क्या होगा? I mean, what is this integral equal to? I mean, there's a concept here that you can use to give the answer just right away and not really bother with this integral.
जो चीज़ q फंक्शन के लिए अप्लाई की थी.
It doesn't require a Q function. I mean, the PDF is of a very specific form, and a specific form which we've been looking at for so long. What is a PDF? What does a PDF look like?
Sir, Gaussian.
Gaussian है, okay, good. फिर Gaussian है, उसका मीन क्या है?
Y over 2.
Exactly.
Sorry, हाँ. Right.
Is Gaussian with a mean equal to what? y over 2. And you can find the variance as well, by the way. I mean, that's easy, right? So just given this observation, that's enough for you to be able to write down what the conditional expectation is going to be. And what is that conditional expectation? That expected value of x given y is equal to y by 2. Right? Because given y, you're just integrating over a Gaussian PDF. Jiska mean y by 2 and the mean should turn out to be equal to y by 2. Right? When you and you can go ahead, by the way, you can go ahead and compute this integral. You will obtain y by 2. And how would you go about this? I mean, you see कि यहाँ पे ऊपर exponential में squared है, नीचे x है, so that's a derivative, if you will, of some form. And there's a change of variables involved as well. Okay? But you don't really need to do that. You can just use the fact or the observation that the PDF is a Gaussian PDF with a mean equal to y by 2. So therefore, the conditional expectation is going to be y by 2 as well. Okay. Now, given this simple exercise, let's try to build on this a little bit more. So this is screen freeze again. Example 2. Okay. So example 2 is just a slightly bit more involved, but not too much. So let's say you have a joint PDF given to you, fxy, x comma y equals 1 upon pi root 3 e raised to power minus 2 by 3 x squared minus xy plus y squared, right? And this is actually from example 5.10, which I asked you to do on your own, which was actually a reading assignment. And it turns out, KG, if you've done that, you would have found out, okay, this is equal to, I mean, after you do some factorizations or some marginalizations, this turns out to be equal to root 2 upon 3 pi e raised to power minus 2 by 3 times y minus x by 2 whole squared times 1 upon root 2 pi e raised to power minus x squared by 2, right? So that's one factorization that you could do. And it turns out, Kitty, there's another thing that you can do here as well, which is 2 by root 3 pi e raised to power. And because of the symmetry, this is x minus y by 2 whole squared times 1 upon root 2 pi e raised to power minus y squared by 2, right? And it turns out, okay, this thing actually here is f of y given x times fx of x, right? So this is what exactly what the problem 5.10 was. Okay, given the joint distribution, find out the conditional density function and the marginal density function, right? So that's what the problem was. And turns out, okay, this turned out to be the final answer, right? F y of y, right? So in other words, this thing here is fx of x, which you can obtain from marginalizations. This here is fy of y, right? And so on and so forth. So ये क्या चीज़ है? This thing here is fy given x, and this thing here is fx given y. Okay. Now, armed with this, you need to do the following, right? So this is something we're assuming we know because we've all looked at example 5.10. and what we're required to find is okay, you're required to find the correlation coefficient between the two random variables x and y, right? How do I go about this now? So what's the definition of the correlation coefficient? Giuseppe?
So it is the covariance of x and y divided by the
Good.
standard deviation of x times
Exactly. So
y.
we know that the correlation coefficient is equal to covariance between x and y divided by the standard deviation of x multiplied by the standard deviation of y. Now, what is covariance of x and y? That's defined as expected value of x minus mu x times y minus mu y, right? Divided by sigma x times sigma y. Can somebody tell me what mu x is and what mu y is and what sigma x is and what sigma y is, given the information that I just wrote above? Ji Abdullah? Given this information in that orange color, if you will, I mean orange, whatever that color.
Mu x equal to 0 and mu y equal to 0.
Excellent. And what about the standard deviations?
Sir, square root 2.
Square root 2? Almost it. Ji Ghazi. 1, right? So they're standard normal, right? So if you look at these expressions, right? If you look at these expressions, this is Gaussian distribution with a zero mean and a standard or a unity variance. So it's a standard normal distribution. Okay? So x is a standard normal random variable and y is a standard normal random variable as well. Okay? And the joint PDF is that awkward looking thing up above, right? So since the mean is 0 of both of the random variables and the standard deviation of both of the random variables are unity, this is just equal to expected value of xy, which is actually the correlation between x and y, right? So this is what we need to find. In order to determine the correlation coefficient, I just need to compute, for this particular example, the expected value of x times y. So that's all I'm going to do. So expected value of xy, let's try to find that out. So this is the product xy times xy x given, oh, sorry. This is the definition of the expectation. Now, what do I do next? I mean, there's a hard way of doing it, and there's a very, very easy way of doing it. And the hard way of doing it is to plug in this expression from 1 into this expression in 2, right? And start integrating, right? And you will be able to obtain some result. I mean, that's possible, that's doable, right? But that's a hard way of doing it. It's a very, very tedious way of doing it. There's a much, much simpler approach. Ji Isha. What is that approach?
Sir, we can see if we can actually separate out the x and y and solve it as a separable integral for x and y.
How so? How do you separate that out?
Sir, exponent ke andar we have terms of Chani, we're going to get terms in x and y both as well, so that would lead it to be hard. Yeah.
So they're not separable. Shoaib, आपने भी हाथ खड़ा किया था.
Sir, I'm not sure about this, but don't we know from our prior knowledge कि अगर x और y Gaussian है, तो expected value of मतलब इन दोनों के product इनका sum होगा इनके means का.
No, not really. जी माज. Maz, I think you raised your hand.
Yes sir. आवाज आ रही है मेरी सर?
जी आवाज थोड़ी हल्की हल्की आ रही है, but go ahead.
अच्छा सर, तो सर आई थिंक ये ऊपर वाले जो हमने कंडीशनल पीडीएफ और ये जो रिलेशन फाइंड किया हुआ है जो ऊपर लिखे हुए हैं वी कैन यूज दैट.
अच्छा, it turns out कि मुझे बहुत कम आवाज आ रही है.
माइक
Is there something you do with your microphone?
माइक्रोफोन खराब हो गया है.
No? Okay. So why don't you try to type it up in the chat box? And meanwhile, let's see if somebody can try to solve this. Who would I ask? Nazish?
I'm not sure. अगर हम ऊपर वाला expression डाल दें,
कौन सा
तो
वाला?
f of y given x into
Good.
f of x.
Right.
उसको
So, okay. So I have this double integral. I have xy. And the product, so let me just replace the joint probability density function as a product of the conditional times a marginal, right? And I could use either one of the two expressions up above, right? So let's pick the first one, right? So this is f of y given x, y given x. Actually, let's pick the second one because that's linked with, yeah. So this is x given y times fy of y, and then there's a dx and there's a dy. Isha, now is the integral separable?
Yes sir, I just realized that, and then I thought कि मैं बिना वजह confused हो गई थी कि मैं कह ही रही थी कि ऊपर वाला कर दें इसमें substitute.
Right? So now you need to be a little bit clever, right? And you see this is integral from minus infinity to infinity. I am going to separate out the integral involving x's first, which I could do, right? So let's have this. And then I have y here, and then fy of y here, dy, right? So this is the trick I play, right? And using that trick, things become very, very easy. And how so? This is minus infinity to infinity, and this is y. What do I get in this integral? ये किसके बराबर है? This is nothing but expected value of x given y, which I have actually done in the previous example, but I can just take a look at f of x given y, which is here, right? And see that this is a Gaussian distribution, right? This is a Gaussian distribution, and the mean for this is y by 2. Right? So I know that this is equal to y by 2. And this comes about from the example that we did previously as well. Okay. So therefore, this is that term inside this blue brackets is actually equal to y by 2 times fy of y dy. So this is integral minus infinity to plus infinity y squared by 2 times fy of y times dy. Achha, how do I solve this integral now? Right, I know what the PDF of y is, right? So this is half integral minus infinity to infinity y squared 1 upon root 2 pi e raised to power minus y squared by 2 dy. What is this equal to? जी माज?
सर मेरी आवाज आ रही है?
जी आ रही है. Good.
सर ये 1 होगा.
Excellent. Why?
सर क्योंकि वेरिएंस है, मतलब एक्सपेक्टेड वैल्यू.
Right, so I don't really need to compute this integral. I mean, this integral can be computed. वो जान जोखा काम है थोड़ा सा अगर आप calculus की basis पे जाएंगे. But we know that this is the variance of y, right? And since y is a standard normal distribution or a standard normal random variable, the variance is 1. Okay. All right. So this therefore becomes equal to 1 by 2. And that's your answer. Okay, that's your answer. So your correlation coefficient for this particular pair of random variables x and y is half. Okay? Any questions here? Yes,
So
sir.
could you explain the variance part in the end? I'm a bit confused about that.
Okay. So you see, this is, what is this thing? This by definition is expected value of y squared, right?
Yes, sir.
Expected value of y squared. But since y is zero mean, so the second moment is
Okay,
actually the
so-
central second moment as well. This, which is the variance, right? So this is the variance of y, which is equal to 1 since y is standard normal,
Okay, sir. Thank you.
right? Okay, any other questions? All right. Okay, so let me move to the next topic here. And that is with regards to independent random variables. So any idea, I mean, when will two random variables be independent? I mean, when do we say that two random variables are independent? Actually, when do we say when two events are statistically independent? कब होते हैं? And this is something we've done. When are two events statistically independent? G. Mohsin?
So when the occurrence of one event does not affect the occurrence of the consequent event.
Okay, but as far as the definitions are concerned, in terms of probabilities.
So a probability of A given B is equal to probability of A.
Good, right? Either, so that's one definition. There was another definition as well. Okay, either, so that's a correct definition. When probability of A given B is equal to probability of A, then we say A and B are statistically independent. Or when the probability of A comma B was equal to the product of probability of A and the probability of B. Okay, so when the joint was equal to the product of the individual probabilities, that's when we said the events were statistically independent. Now we want to go a step further and go from events to say something about statistical independence between two random variables. Okay, so two discrete random variables are said to be independent if probability of this joint PMF turns out to be equal to the product of the marginal PMFs. Right? And the key here is that this needs to be satisfied for all x and for all y. Okay? So actually the joint PMF function, right, evaluated at any x or any y turns out to be equal to the product of the marginal PMFs of both of the random variables at that x and at that y. And this needs to be satisfied for all x and for all y. Okay? So that's a definition of statistical independence between two discrete random variables. And for continuous random variables, we have that the joint PDF must be a product. Times Fy. And this must be for all x and for all y, right? If this condition is satisfied, we say that the two random variables x and y are statistically independent. And you can actually verify that if this condition is true, this actually implies that the conditional PMF or conditional PDF of x given y is actually equal to fx of x. And this implies that if y given x times fx of x for all x and y. And there are two-way implications here, by the way. Right? So either one of these three conditions are, so all these three conditions are equivalent to each other. They're the same, right? And if therefore, if either one of these three conditions are satisfied, we say that the random variables capital X and capital Y are statistically independent. Okay? And these two definitions here, I mean, for me, they're more intuitive, by the way. I mean, when you say, as Mohsen started out as well, because for me, they're more intuitive because what you're saying is, okay, the PDF on X conditioned on what Y is does not change with Y. It's not a function of Y. No matter what Y is, the PDF of X stays the same as if there was no conditioning, right? So the conditioning therefore does not change the distribution. And that would imply that, and that basically intuitively means that they're independent. Okay, so that's why it's more intuitive for me, right? But nevertheless, more commonly perhaps used is this definition, by the way, right? When you say that the joint PDF is equal to the product of the marginal PDFs, that's when the random variables are said to be statistically independent. Okay? Any questions here? So let me just have a quiz, if you will. Okay. Fx of x is, this is actually the previous example that we did. 1 upon root 2 pi e raised to power minus x squared by 2. And if x given y, x given y turns out to be equal to root 2 by 3 pi e raised to power minus 2 by 3 x minus y by 2 whole squared. Are x and y independent? Okay, so if you could all use Zoom for voting, there's a yes and no, right? You may be able to see that yes or no. How many of you think that these are independent? Or independent or not independent? Nobody thinks anything? Okay. There are only two people who think something. Baki other.
Where do you vote from?
Right, so you on Zoom आपके पास है ना एक options है yes or no की option है. The question is, are x and y independent? What's your answer? Okay, जिसने आंसर नहीं दिया, अली. Ali, do you think they're independent? All right. Yes, Ali, please, could you unmute yourself?
Yes, sir.
So you think they're independent? Is that what you're saying?
Wait, sir.
Okay, Abdullah, why do you think they are not independent?
Sir, you have written a definition about f of x given y must be equal to f x of x. So seeing the expression, they both are not equal. So they are not independent.
Good, excellent. So they're not independent because the conditional PDF is not the same as a marginal PDF. So they're not independent. Okay? Acha. Let me ask you another question. Example 2. So fx y, you're now given the joint PDF, which is equal to 1 for all values of 0 and they're 0 otherwise. So are x and y independent here? So how should I go about finding whether they're independent or not, or determining whether they're independent or not? Ji Ali? Jelly, go ahead, please.
जी सर मैं कह रहा हूँ सर इसमें कोवेरियंस देखी जाएगी कि
No covariance. Why covariance?
अगर को
I mean, we've not said anything about the relationship between covariance and independence yet, right? So the only thing we said about independence is the two random variables are said to be independent if the conditional PDFs are the same, or conditional PDF is equal to the marginal PDF, or if their joint PDF is equal to the product of the marginal PDFs. Okay, so we won't look at the covariance. Mohsin, you also raised your hand. Would you go ahead?
Sir, मैं जरा reconsider कर रहा हूँ.
Okay, Ghazi.
I think the intuition is that we hold one value of x and we say कि हम y को चेंज करने से क्या वही वैल्यू रहती है. तो इन अगर हम इस सर्कल के अंदर इस स्क्वायर के अंदर रहेंगे तो वो वैल्यू रहती है, तो लेकिन उसके बाहर जाएंगे तो जीरो हो जाएगी. So they're not independent.
But लेकिन हो सकता है उसके अंदर वैल्यू चेंज हो जाए.
उसके अंदर वैल्यू सेम रह रही है ना.
How do you know?
Function defined वैसे.
Okay, but I need a non-intuitive way of going about this. A rather rigorous way of doing it. G. Mohsin, have you reconsidered? Go ahead.
सर अब इसके एक्सप्रेशन को अगर एक्सटेंड करेंगे x इंटरसेक्शन y को इक्वेट कर दें with x given y into f of x, तो वो आपको
I don't know what the PDF on x is. I don't know what the PDF on y is either. तो फिर I mean, how do I even go about this?
So मैं assume कर रहा था पुरानी information अभी भी आपके पास.
पुरानी नहीं है, बिल्कुल नई information है. Maz?
सर आई थिंक मार्जिनल कंप्यूट कर लें दोनों, मतलब एफ ऑफ एक्स ऑफ एक्स और एफ एक्स वाई ऑफ वाई, और उन दोनों का प्रोडक्ट ले लें जैसे ऊपर वो.
Right. So the way to go about this is to compute the marginals first and see what the marginals turn out to be, right? So I compute the marginals, and the marginals is defined as integral from minus infinity to infinity fxy xy, and what do you marginalize over? You marginalize over dy, right? Or marginalize over y, right? And therefore this is 0 to 1, because that's the, as long as y is in between 0 and 1, that's the only place where the joint PDF is equal to 1 and 0 otherwise. So this is 1 and dy, and this is 1. Okay, so is the conclusion, yeah, conclusion fx of x equals 1? Is that the conclusion? जी मोहसिन.
सर आप इसी तरह y को marginalize करें और फिर उनका product करें.
Is this a valid PDF? I mean, if you write this out, and I'm going to deduct points for this because it's not a valid PDF. fx of x equals 1 means it stays 1 from minus infinity to plus infinity.
So between 0 and 1.
Between 0 and 1. Good. Okay. So this is equal to 1 only when 0 is less than x is less than equal to 1. And that comes about from the fact that यहाँ से this integral is equal to 1 only when x is between 0 and 1. As soon as x goes out of this interval, outside the interval 0 and 1, the joint PDF drops down to 0, and therefore the integral is 0 there as well. Okay? So this is fx of x. And similarly, I can conclude the same about y, because everything is symmetric. This is going to be equal to 1, 0, 0 is less than equal to y is less than 1, and otherwise. Now you have enough information to be able to determine whether the two random variables are independent or not. Are they independent, Ghazi?
My intuition says no, they aren't independent.
Why does your intuition say why they are not independent?
Okay, so we say कि f of x की value है.
Yeah.
What is the probability of x 0.5, right?
No.
अगर if it's given कि y is equal to 0.2 है, then it's 1.
Yeah.
लेकिन अगर y given है कि -5 है, तो it's 0. तो आपकी f of x की PDF change हो रही.
No. 0.5. So you're confusing something about the PDFs and the values that X can take. So X and Y are jointly uniform in a square, inside a square of area 1. Okay? And X is a uniform random variable between in the interval 0 and 1. Y is a uniform random variable in the interval 0 and 1. And all I need to check is just multiply these marginal PDFs together and see if I get the joint PDF. Ji Mohsen?
I think the rigor says that they are.
Rigor says they are, and the intrusion tells you they are the same. Why? Because, so let me hear Mohsen first, and I'm going to come back to us.
So मैं कहने लगा था कि अगर आप इन दोनों PDFs को मल्टीप्लाई कर दें तो शायद गाजी का आर्गुमेंट हो जाता है सेटिस्फाई जो उन्होंने कंडीशन दी है.
जो गाजी का आर्गुमेंट है वो नलिफाई हो जाता है.
Yes sir.
Right. So if I multiply, so it's clear. fxy xy is indeed equal to the product. And you multiply these two margins together, that's the joint PDF is something you're going to get. Okay. And you can then say that yes, conditional ko nikalu. Conditional actually comes about from this. The rigor tells you that conditional we condition satisfy karegi. The conditioning on y does not change x. Okay. Now, if you want to have some intuition about this, right? So x and y, remember, are jointly uniform. Okay, sorry, jointly uniform in this region. In this region, they're jointly uniform, right? And if I give you a certain y, and you say, I've observed y to be here, it turns out x is still uniform between 0 and 1. And no matter what y is, uniformity barqarar rehti hai uski. Uniform randomness barqarar rehti hai. And therefore, it's independent of y. X is independent of y and vice versa.
Can we take a little digression into my intuition?
Into
my intuition. I'm saying, sir, if we calculate f of x given y, x is less than 0.5 and y is less than 0.
Yeah.
Okay? And normally we do it f of x y over f of y. Okay?
But that turns out to be 0, that probability.
इस केस में अगर y less than 0 हुआ तो फिर infinity आ जाएगी क्योंकि हम 0 से divide कर रहे हो.
नहीं. So if you go back and say कि जो conditional वाली चीज में थी, when you're dividing by 0, what you're dividing by cannot have a 0 probability.
वही ना, तो मतलब कोई मसला तो है ना.
ये मसला कोई
आपका ऐसा डोमेन है जिसके ऊपर वो satisfy नहीं हो रहा. f of x given y is equal to f of x.
So I'm not exactly sure what you're saying. So masla koi bhi nahi hai. That's a bottom line. But I do want to perhaps talk to you afterwards, Razi.
हाँ, ठीक है.
ठीक है, मसला ताकि जो है उसको resolve कर लें. Okay. And let me just, I've actually spent much more time than I wanted to. And this is something I don't have in my notes, but I'm going to put this out nevertheless. Okay. Fxy xy equals some constant as long as x squared plus y squared is less than or equal to 1 and 0 otherwise. Remember, this is one of the other screen. I wonder why this happens. Oops. Okay. Okay, so this is example number 3. I mean, this is an example that we've done before, right? So this is x and y are uniformly distributed inside a unit circle. Right, so this c is really 1 by pi. Right? Do you think x and y are independent? So I'm not going to write anything here, but they're G Mohsen?
No, sir.
They're not independent.
सर हमने derive किए थे marginalization से कि x का expression is dependent on y और y का would be dependent on x.
बिल्कुल. So that's one way to do it. I mean, if you want to really do it rigorously, that's what you can do. What we've done already. जहाँ पे margin भी derive किए थे, हमने conditional भी derive किए थे, and it turned out the conditional of x on y turned out to be dependent on y because that reduced the interval in which it could be, right? So you go back to that example and look over it again, right? But there's some intuition here that you can employ as well, because as y changes, right? For example, y is close to 0. If y is close to 0, you know that x is in between -1 and +1. But when y is close to 1, you know that x is going to be distributed very, very close to around 0, in a very, very small interval around 0, right? So that interval in which that x is distributed changes as y changes. And that's some intuition that tells you that yaar, waqai x and y cannot be independent, statistically independent. Okay? Because the distribution of one changes given the observation of another. Okay? Now, I just want to give out a theorem here, which I'm not going to prove, but which is intuitive, quite intuitive, which is that if x and y are independent or statistically independent, u equals g1 of x and y equals g2 of y. So v is a function of y, some function of y, and u is some function of x. Right? The theorem then states that u and v are also independent. Right? That's what the theorem says. I'm going to skip the proof. Right? There's another theorem here. And the proof for that is quite simple, and we're going to do. If x and y are independent, Rxy is actually equal to the product of the means and covariance between x and y, that is equal to 0, and therefore the correlation coefficient is also 0. Okay. So how do I go about proving this? The proof is very, very simple. Rxy, remember, is defined as expected value of xy. So this is integral xy, fxy, xy, dx, dy. But since they are statistically independent, this is fx of x, fy of y. The joint PDF is equal to the product of the marginal PDFs. And now the integrals are separable. I can separate them out. This is equal to x fx of x times dx times y fy of y times dy. And this is nothing but expected value of x times expected value of y, which is mu x mu y. Okay, then mu x mu y. And since cxy, or the covariance between random variables x and y, is defined as the correlation minus the product of the mean, and the correlation there is equal to the product of the mean, so therefore this must be 0, and this completes the proof. And this implies that rho xy equals 0. Right? So conclusion kya hai? Right? What's the conclusion? The conclusion here is an important conclusion. Ji Mohsen.
So x and y are orthogonal and uncorrelated.
X and y are not orthogonal. Orthogonal tab hote hain jab unki correlation 0 hoti hai. I'm not saying the correlation is 0. I'm saying the correlation is equal to the product of the means. Right? The conclusion is okay, if X and Y are independent random variables, if they are independent random variables, they are uncorrelated as well. They are also uncorrelated. Right? That's an important conclusion. Okay, two random variables which are statistically independent, they must be uncorrelated. Right? And uncorrelated in the sense that their covariance would be equal to 0. Okay? What about the converse? So what do you think? So here's the question. Is the converse true? In other words, if X and Y are uncorrelated, are they always independent? क्या ख्याल है? I mean, if I इतनी बड़ी मैंने तमहीद मान दी है तो आंसर क्या होगा इसका? So what do you think, Azi?
Yes.
Yes. What do you think, Isha?
Sir, they may not always be independent.
The answer is no. Right? And if you know if the answer is no, what's the how do you prove that? I mean, how do you prove this negation, if you will? I mean, this is a negation, right? I mean, what you want to prove is if X and Y are uncorrelated, they are not guaranteed to be independent. I mean, that's what you want to prove. इस तरह की चीजें प्रूव करने का क्या तरीकाकार होता है? जी मोहसिन.
So proof by contrapositive.
What does that mean?
Sir, if A implies B, then B complement should imply A complement.
I mean, if you want to show that something is not always guaranteed to be true, all you need to do is just find one counterexample. Right? That's all you need to do. I mean, that's how you prove that. Right? If you want to prove that if X and Y are uncorrelated and you want to prove they are not always guaranteed to be independent, all you need to do is just find one example. And that one example is enough to prove that result. Okay? So all I need to do is find a counterexample. So following is a counterexample. And there are many, many, by the way. So let X be zero main Gaussian random variable with variance sigma squared. Okay? And let Y equals X squared. Right? Are they statistically independent or not? चलिए ये बताएं मुझे पहले. Is Y and X, are Y and X statistically independent?
Sir, dependent.
Yeah, they're dependent. Why are they dependent? चलिए बताएं मुझे.
Sir, Y is clearly depending upon the value of X squared. So
Clearly. Clearly. So Y is clearly dependent on X. Given X, right? You exactly know what y is, right? So given y, do you know what exactly x is?
Square root.
So this was a homework problem, by the way. So given y, do you know what x is? और उसकी PDF क्या है x की? चलो ये this is sort of a digression here. लेकिन so given y, x is actually a discrete random variable with a probability equal to plus root y, with a probability of half of it being equal to plus root y and the probability half of it being equal to minus root y. ठीक है, दो deltas आती हैं उसमें, ठीक है, but that's was actually in the homework, something to think about, something to ponder about, एक लिखा हुआ था. Okay, so but that of course does not mean that they're statistically independent, right? They're still dependent. Okay, so given that they're dependent, let's try to find what their covariance is. Okay, so I will find the covariance. The covariance x y is defined as expected value of x minus mu x times y minus mu y, right? By the way, mu y क्या है? Just a quick quiz here. What is expected value of y? What is expected value of y? Ji Ghazi?
Sigma squared.
Sigma squared, right? So this is expected value of x squared, and that is sigma squared. Because it's Gaussian and zero mean. If zero mean, so the second moment is the variance of which is sigma squared. I mean, but that's besides the point, right? So this is expected value of x. What is mu x? Mu x is zero as well, and this is y minus mu y, right? And therefore this is expected value of xy, because expectation is linear, minus expected value of x
Sir, it's not
times
visible on the screen.
mu y. ठीक है? Isha, can you see that now?
Yes, sir, it's visible.
Right, right. So I know that this is 0. So therefore, this is equal to expected value of xy. What is the expected value of xy? This is expected value of x cubed. Right? I just plug in y equals x squared here. So expected value of x times y is expected value of y cubed. What is expected value of y cubed? Oh, sorry. What is expected value of x cubed? What do you think it would turn out to be equal to? What should it turn out to be equal to? Yimaz, क्या ख्याल है? So this is equal to 0. Right, and that should be quite straightforward. Why? Because x cube is an odd function, right, or anti-symmetric around 0. Okay, and the Gaussian PDF with the 0 mean is symmetric around 0. Okay, you multiply the two together, what you get is anti-symmetry, and you take the area in the curve, that area in the curve would be 0. Okay, that's a simple argument that you use. Okay, and from here we conclude that for these two random variables, the covariance turns out to be 0. That means they're uncorrelated, right? So what you found a counterexample of two random variables that are dependent on each other, yet they are uncorrelated. Okay, and that's a proof that uncorrelatedness does not always imply independence. That's a proof of that. Okay, so these are X and Y random variables are dependent yet uncorrelated. Right, so the conclusion we have here is that independence this implies uncorrelatedness. Correlatedness, even if that's a word, but not the other way around. I mean, यहाँ पे ये चीज नहीं है, right? So there's only a one-way implication, right? Not a two-way implication, right? So independence implies uncorrelatedness, but uncorrelatedness does not necessarily imply independence. ठीक है? फिर then the question is, if you go back to some intuition, yeah, I mean, what does covariance really try to capture for you? Right, so that means you've encountered examples in which two random variables are uncorrelated with each other, yet they are independent, or yet they are dependent. ठीक है? तो फिर covariance is not really capturing statistical independence in a full blown fashion. Right, तो फिर क्या capture करिए? It turns out that covariance or the correlation coefficient, and I said this earlier as well, is sort of a measure of how, or the degree of linear dependency between two random variables, right? And it just tries to see, can you fit a straight line to it or not, right? And if you cannot fit a straight line to the scatter, or if there's no linear relationship, statistical linear relationship between X and Y, that would mean that they're uncorrelated with each other, but that does not necessarily mean that they are independent, because there may be non-linear dependencies between them. Okay, so this is some intuition, all right? So when simply put, covariance or the correlation coefficient tries to capture the linear dependency between the two random variables X and Y. Okay, and if the covariance or the correlation coefficient turns out to be 0, that means there's no linear dependency between them. Okay, so independence is much broader, much more general, and covariance, uncorrelatedness is a subset, if you will. Okay, any questions here? Okay, so we have 5 minutes. I will just introduce the next topic, and then talk about more details when we come back on Tuesday. So that topic is about jointly Gaussian random variables. Okay, so we talked about Gaussian random variables. Now we want to generalize this further to jointly Gaussian random variables. Okay, two random variables X and random variable Y, they are said to be jointly Gaussian. They are said to be jointly Gaussian if their joint PDF follows or is of the form. Is of the following form. So, and that form is fxy xy equals 1 upon 2 pi sigma x times sigma y, 1 minus 1 minus rho squared e raised to power minus x minus mu x whole squared divided by 2 plus y minus mu y whole squared divided by 2 minus 2 times rho x minus mu x, y minus mu y, and there's a bracket here, divided by, whole divided by 1 minus rho squared. There's a, okay, so I'm missing some terms here. This is sigma x. So I'm just giving you this expression here, and we're going to continue next time. Sigma x squared, sigma y squared. Okay, there's a bracket outside. All right. Now, a complicated looking expression, but we're going to take a look at just what this looks like in 2 dimensions and try to extract what do these variables represent. By the way, these sigma x is the standard deviation of x, sigma y is the standard deviation of y, mu x is the mean of x, mu y is the mean of y, and rho kya hai? Is a correlation coefficient. Okay, it can be verified. And I'll let you do this because this is going to be tedious, but it's doable. That when you obtain the marginals, if x of x turns out to be equal to 1 upon root 2 pi sigma x squared e raised to the power minus x minus mu x whole squared 2 sigma x squared, and fy of y equals 1 upon 2 pi sigma y squared e raised to the power minus y minus mu y. Okay. So this is something for you to try on your own. Okay. And actually, let me write something else as well. Something else for you to try. Is also Gaussian with the mean equal to mu x plus rho sigma x by sigma y, y minus mu y. This is the mean, and sigma x squared. So this involves quite a lot of tedious calculus, but it's provable. And this may actually be there in the textbook. Okay, so I'm going to leave this in front of you or in the notes as well. And the next time when we come back, I just show this expression and then go to a demo where I just show you the 2-dimensional plots, or actually the 3-dimensional plots. Okay, what does this actually look like? I mean, what is really going on? Okay, so I'm going to stop here. Any questions? I know these ke baare mein questions now. I've just written these down for you without really explaining anything. But questions from the previous topics that we covered, if there are any, let me know. Okay,